are going to explain about hotspot zone detection to tackle COVID-19 spread by fusing the traditional machine learning and deep learning approaches of computer vision. Introduction. Coronavirus is a pandemic and the whole world is affected due to it. Apart from the vaccine, the only cure for the drastic disease is to follow the rules and regulations that avoid further spread. There are different mechanisms like social distancing, mask detection, human occupancy, etc., through which we can able to stop the spread of the coronavirus. In this project, we propose hotspot zone is detected using the computer vision techniques of deep learning. Drawing hotspot zone and then YOLO V3 will detect the objects and then deep sort will track the detected object is a person or not, and then using template matching and distance will check whether the person is close or touching to hotspot zone. If touching to hotspot zone crosses the threshold, then system will display alert by saying touching the hotspot zone. Touching will be detected using template matching and then finding the intersection between person location and hotspot location, and this process is called extracting region of interest. Objective. The objective of this project is to utilize machine learning and deep learning computer vision technique to detect hotspot zone in corona affected areas. The proposed approach involves manually drawing the hotspot zone and then using YOLO V3 for object detection and deep sort for person tracking. By applying template matching and distance calculation, the system checks if a person is in close proximity or touching the hotspot zone. If the person crosses the threshold of the hotspot zone, and the alert is triggered. To further enhance the safety measures, the extension aims to include distance detection between two persons, ensuring sufficient distancing and face mask compliance, with alerts sent to the authorities when necessary. Requirements of the project are hardware requirements and the software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. Methodology. We have designed 3 modules for the execution of the project. In the first methodology, which is load YOLO V3 deep sort model, using this module, we will generate the YOLO V3 deep sort model. Next module, which is upload video and detect hotspot zone. Using this module, we will upload the video file in this video. In this video file, we will have a defined hotspot zone using red color bounding box. This module will read each frame from the video and then apply YOLO algorithm to detect person touching hotspot zone or they not maintain sufficient distance. Last module, which is accuracy graph. Using this module, we will plot YOLO V3 training graph of accuracy and loss values. Execution. For execution of the project, first open the code folder. So this is the code folder and this is the video file on this which we are going to test. And this is the YOLO V3 model. In this folder, we have the pickle file stored in it which contains the algorithm information. These pickle files can be loaded into the project code during runtime to utilize the train models. And this is the main code file which contains the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we have created the Windows batch file for execution of the project. So double click on it for execution. So this is the graphical user interface of the project. With this, we will be interacting with the program. So click on the YOLO V3 button to load the YOLO V3 model. So here the model is loaded. Next, click on the button upload video and detect hotspot zone to upload the video. So select the video, click on open. In the above screen, algorithm detected the persons in yellow color and hotspot zone in red bounding boxes. So the location defined by us and then persons which has less distancing is alerting by displaying message as too close and then showing the output as hot zone touching when person is too close or touching to hotspot location. Click on the accuracy graph. Here on x-axis, the epoch is represented and on the y-axis, accuracy and loss is represented. With the increase in the epochs, accuracy has been increased and with the increase in the epochs, the loss is decreased. Close the graph. Conclusion: the proposed approach utilizing the machine learning and deep learning computer vision techniques effectively detects hotspot zones in the corona infected areas by manually defining the hotspot location and employing the YOLO V3 for a percent detection, and deep learning sort for tracking. The system identifies individuals within the vicinity. The extension to the assess distance and generate the alerts for too close encounters enhances social distance measures. Detecting the individuals touching or being in close proximity to the hotspot zone location is crucial for timely intervention. Overall, the system showcases the promising results in alerting potential risks, aiding infection controls, and ensuring the public safety. Its applicability to different videos reinforces its potential in real-world scenarios, contributing to a safer environment aid to ongoing pandemic.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.